Dear students, Assalamu alaikum and welcome to Digital Learning Al Noor International School. Here your chemistry teacher Fraz Anjum. Today we will discuss chapter 24, the chemistry of life, lesson number 4, lipids. In this lesson, our main objective, identify the physical property that distinguish lipids from the other biological molecules. The resources and object you need: textbook, notebook and workbook. And please open the chapter number 24, lesson number 4, lipids in the book. Let us start to the lesson. First of all, describing the lipids. What is lipid? So fats, oils and other water insoluble compounds are called lipids. This is the simplest definition of the lipids. So anyone who asks you what is lipid, so you can answer fats, oil and other water insoluble compounds are called lipids. Now the question is, what physical property distinguished lipids from other classes of the biological molecules such as carbohydrate, protein, etc.? So answer is, carbohydrates and protein tends to dissolve in water. Means carbohydrate and protein can dissolve in water, whereas lipids tends to dissolve readily in organic solvent such as ether and chloroform. Means lipids cannot dissolve in water, but it can very much dissolve in organic solvents such as ether or chloroform. Now, the main group of the lipids called triglyceride. What is it? Natural fats and oil exist as triester of glycerol with the fatty acid, which are long chain of carboxylic acid, carbon 12 to carbon 24. This is the combination of glycerol one side and other side fatty acid, glycerol and fatty acid. And remember, fatty acid, what is it? A long chain of carboxylic acid. So this form the lipids known as triglyceride because of these two, means glycerol and fatty acid combined together. That's why it's called triglyceride. Now triglycerides are important as the long-term storage form of energy in the human body. Okay, let's guys start with the triglyceride. The following equation shows the general reaction of formation of triglyceride. So how triglyceride going to form? Remember this molecule? It's called glycerol. In the previous lesson we discussed this, glycol and glycerol. Glycol and glycerol. If the compound or alkane contain 2 OH, this is called glycol, and if it has 3 OH group is called glycerol. Okay, glycol as anti-freezing, here glycerol for the cosmetics, if you remember. Good. Now can you identify this functional group? Exactly right. I hope that you all guessed this. Carboxylic acid, and commonly called fatty acid molecules. Altogether 3. So 3 fatty acid molecule. Okay. So what's going to be happen here? Glycerol combined with the 3 fatty acid molecules and eliminate 3 molecules of water. How? Look here. In glycerol side, each OH group give hydrogen ion, and from carboxylic acid side, each carboxylic acid or fatty acid give the OH group. So H plus OH combine together and make the water molecule. So one water molecule eliminate from here, then one from here and one from here. and produce 3 water molecules. So all the valency free here, all the valency free here, they can join together. After joining, they make triglyceride. So why we call triglyceride or triester? So focus here a little bit. RCOO, what is it? H, and H, CH2. CH2 or any chain, remember I told you, consider as a R, alkyl radical. So RCOOR, what is the functional group of this? This is general formula of ester. So how many ester here? 1 ester, 2 ester, 3 ester. That's why we call triester of glycerol. Okay, why glycerol? Because it looks like this. Okay, or simple way we call triglyceride. I hope you understand the structure. Now the most important process in this lesson is saponification. What is saponification? So simple wording, you can say the process in which we can prepare the soap. Now in this process, this is the hydrolysis of oil or fat by the boiling with an aqueous solution of an alkali metal hydroxide is called saponification. Saponification is used to make soap. Soap are thus the alkali metal, sodium, potassium and lithium salt of fatty acid. So simple thing, saponification, because of making the soap, that's why it's called saponification. This process is called saponification, okay, or soap preparation. Now this is the hydrolysis of oil and fat, remember. So when you put sodium hydroxide, potassium hydroxide or lithium hydroxide into the oil or fat and heat or mix together, after that you can prepare the soap. This process is called saponification. Now look at the final. This is the typical saponification reaction is shown below. This is triester glycerol and stearic acid going to combine with sodium hydroxide. When you mix it, the glycerol side eliminate. So all the glycerol side going to eliminate this side. So all this side going to eliminate it from this. Okay, from these covalent bond going to break it, and then one hydrogen going to attach on it, and it become again glycerol. Now what left here? So from this sodium side, okay, it's going to attach again. Okay, it's going to attach again the sodium here. So it makes sodium stearate, okay, which is a soap. Now the second group of lipids, phospholipids. Lipids that contain phosphate group are called phospholipids. Phospholipids are abundant in cell, means in the cell membrane. The most common example is cell membrane. So this is the typical lecithin molecule. So the lecithin molecule has a hydrophilic, water-loving ionic head. This is, and this side, remember, have phosphate. Okay, and oily or hydrophobic hydrocarbon here, and this side is hydrophobic tail. This is hydrophobic and this is hydrophilic. What is mean by hydrophilic and hydrophobic? Hydro comes from the water, okay, so water, philic means lover, so water lover head, so means this side can attract the water or can dissolve the water, okay, this side, because it has the phosphate group here. But from this side, hydro comes from the water, and phobic means phobia, like a phobia means hate, okay, so hydrophobic means water hating tail here. So this side is typically fat or oil side. So it contains as two side. One is hydrophilic side, which is head, and other one is hydrophobic side, which is tail. Okay, boy, let's explain this now. In water, phospholipids spontaneously form a spherical double layer. called lipids bilayer. What is mean? Bi means two, layer means layer. Okay, so lipids layer. So this is first layer and this is second layer. So that's why this is all together is called lipids bilayer. Lipids bilayer, and it's present in the cell membrane, most common place. So how it look like? See, you can observe here all the heads either inside or outside. Okay, is the face of the head is inside the cell or outside the cell. It's not like here. Okay, why? Because inside the cell there should be water, outside the cell it could be water as well. Okay, so that's why it's called hydrophilic side, all together outside, like a burger. In the burger, bread are outside, so the bread thing like this is a head of this layer of phosphate side. Now inside, all the tails, look here, all the tails are inside, all the tails are inside for both layer, and make like a sandwich inside, like a kebab or fillet or anything you can see. Okay, so it makes the cell membrane layer by lipids bilayer. So in which the hydrophobic tails or phospholipid molecules are sandwiched between the two layers of hydrophilic head. So see this is hydrophilic head, this is hydrophilic head, and tails are hydrophobic side are the sandwich of this. This is the structure of cell membrane. Now cell membrane consists of primary of lipids bilayer. The hydrophilic head are in contact with the water. Look here, this is water outside, inside water, but the hydrophobic tail are not, and the hydrophobic tails are not, because it's inside, it's safe. Now the last group, or another group you can say, not the last, waxes. Another type of lipids are waxes. Waxes are ester of long chain fatty acid and long chain of alcohol. The hydrocarbon chain for both the acid and the alcohol usually contain from 10 to 30 carbon atoms. So waxes are low melting and stable solid. Okay, now after the wax, boys, what is the major physical difference between the lipids and other biological molecules like carbohydrate and protein? This question normally asks by the in the reasoning. So the reason is carbohydrate and protein are soluble in water, and lipids are often not soluble in water but rather are soluble in non-polar organic solvent. It's like this, we know this one, like dissolve like. Okay, so like dissolve like means polar dissolve polar, non-polar dissolve in non-polar. In non-polar organic solvents such as chloroform, ether, like this. Okay, so lipids tends to dissolve readily in organic solvent, whereas carbohydrate and protein tends to dissolve in water. Remember this. Thank you so much, guys. I hope you understood the lipids. I try to my level best to cover all the major areas of this lesson, but for detail you can go through to the lesson, and any question ask me on the comment in Schoology, and I hope for the best. Good luck, boys. Thank you.